Welcome everyone. The question is, one end of a steel wire is fixed to ceiling of an elevator. So let us consider it is an elevator, and this is one end of the wire is connected to the ceiling of an elevator. This elevator is moving upward with an acceleration 2 meter per second square. Okay, and the load of 10 kg mass hangs from the other end. One end is hang to the ceiling of the elevator, and another end, a 10 kg mass is hang from here. Okay, so this system, we can say this 10 kg mass hanging from a fixed support, this system is inside the elevator, inside the accelerating reference frame. Area of cross section of the wire is 2 cm square. The longitudinal strain in the wire, we have to find it out. Young modulus is 2 into 10 to the power 11 Newton per meter square. Obviously it is the materials thing. 4 options are given: 4 into 10 to the power 11, 3 into 10 to the power minus 6, 8 into 10 to the power minus 6, and 2 into 10 to the power minus 6. One thing need to be noticed, that longitudinal strain have no unit, since it is a ratio of the elongation divided by the initial length. So if both are represented in meter or both are represented in centimeter, in that particular case a longitudinal strain have no unit, so no units are given here. Okay, so just try to understand that. If I try to understand that what is the force that is acting on it, okay, since it is moving upward, so you can say the reaction force of it is acting on it, and that is equal to ma. In addition to that, the gravitational force is also acting downwards. Okay, what is ma? Since this elevator is moving upward, so the reaction force acting on this mass is ma opposite to that of its motion, and mg is the weight of it, that is the gravitational force. That's why you can say the tension force, or the deforming force, which is responsible for the elongation of this wire, of which the cross-sectional area and the longitudinal strain is given, and the Young modulus, we have to find it out, and Young modulus is given, it is that. So I can write it down, the deforming force, that is capital F. Capital F equal to ma plus mg. Ma is the reaction force, or we can say not only the reaction force, this force is added, which is called the pseudo force. If a particle is within an accelerated reference frame, then this pseudo force is acting. Okay, this force is acting, ma is acting on it, and we are just adding this, we are making this reference frame as a Newtonian reference frame or the inertial reference frame. So by adding the pseudo force with the real force mg, we are basically making this elevator reference frame as a Newtonian or inertial reference frame. Now I can use the whatever the law of mechanics and everything. Okay, so ma plus g. M is 10 kg, so 10 is written here. Acceleration is 2 meter per second square, and g is, I am considering 10 here. So this will be 10 plus 2 is 12. 12 into 10 is 120 Newton. So 120 Newton is a deforming force acting on this string. Okay, acting on this string. But try to understand that if the elevator is not moving, if it is not in accelerated reference frame, if it is in an inertial reference frame or a Newtonian reference frame, then this ma does not come into play. At that time, the force acting downward, it is only 100 Newton, only the gravitational force. Since this system is moving upwards, so Ma is added here, the pseudo force is added here. Okay, so it becomes a 120 Newton. Now, this deforming force is capital A, and the area of cross section capital A, it is equal to 2 centimeter square. So I can write it down. Centimeter to meter, we have to divide by 100. Here is a square. So we have to divide by 1000, 1 after that 4 zeros, so 10 to the power minus 4. So it is meter square. Now, the longitudinal strain we have to calculate. So, Young modulus equal to longitudinal stress divided by longitudinal strain. Okay, so we want to calculate the longitudinal strain here, which is basically the longitudinal stress divided by y. Okay, so longitudinal stress is capital F divided by A. Okay, divided by y. So it becomes F divided by AY. Okay, now I am putting the value of the F, the value of the cross sectional area, and the value of the Young modulus here. So capital F is 120, capital A is 2 into 10 to the power minus 4 multiplied by y, so 2 into 10 to the power 11. Okay, so here 2 and 2 is 4, so I can write it down 120 divided by 4, 10 to the power 11, 10 to the power minus 4, I can consider it as a 10 to the power 7. 10 to the power 7 in the denominator, if it goes upwards, on the numerator we can say it is 10 to the power minus 7. So it will be 30. So it can be written as 3 into 10 to the power minus 6. Longitudinal strain, I repeat again, it is a ratio of the elongated length or the change in length divided by initial length. Since both are expressed in length, since both are the ratio of the same type of quantities, longitudinal strain, that's why it has the no unit 3 into 10 to the power minus 6, and option B is the correct answer here. Thank you all of you.